Today's lesson is 12.2. Whoa. Make that a 2. Addition and subtraction equations. And go ahead and set up your Cornell notes. I'm going to keep talking, so if you need to pause it so you can copy it down. Remember, the date you put is just whatever date you're doing it, not necessarily the date I'm making the video. This explore activity, I wanted to zoom in on it because the puppy is just so darn cute. A puppy weighed, this puppy, I guess, weighed 6 ounces when he was born. And then after 2 weeks, the puppy weighed 14 ounces. How much weight did the puppy gain? He's so cute. When you write an equation, remember it's going to be, let me see here. Let me get a different color. It's going to be with an equal sign. Okay, remember because we talked about equations has the word equal. So where did the puppy begin? He started out at 6 ounces, so that should be the first number. And then we don't know how much to add to that, but that amount that you would add to it is what the puppy is gaining. And then when they took the weight again at the end of 2 weeks, he was at 14 ounces. So this is your equation. 6 ounces plus some amount that we're going to have to figure out is 14 ounces. When you look at the model for that, which is really what they want us to do, you have the 6, oh my gosh, my children and my husband, he's making them laugh and stuff right before bedtime. 6, here's your 6 ounces, 1, 2, 3, 4, 5, 6, and then when you see a bar like that, they have an X on it. That means we don't know how much that is. Okay, so we add the 6 plus whatever that is that we don't know what it is, and it's going to equal 14. This right here is like the middle of your scale that balances. This side needs to equal this side. So how much would we need to add to the 6 to equal 14? Well, you'd have to add 8. So that means that this X right here represents 8 for this problem, not every time. Okay, so we're going to practice solving equations, not necessarily modeling them. So I'm looking at example 1 right here. And we are going to set up, well, you have your Cornell notes already set up. Okay, but we're just going to go ahead and solve it. So it says example 1, and I'm just looking, you guys, right here, where it says example 1. Okay, I'm just copying it down in my notes, and in a minute we're going to do these other examples, but just follow along in the notes. Good grief, I don't know why I can't move these things right. Okay, so example 1 was a plus 15 equals 26. And the goal, or what you want to do, is get a by itself so that your final answer says a equals whatever. And in the past, you could just do this in your head, like one of my students would tell me, well, this is easy, I can do this, I don't need to watch the video. But you need to practice these steps because it won't always be this easy. So I want you to do this. You have a plus 15 equals 26. You're going to do minus 15 on one side and minus 15 on the other side. It's kind of like a fraction. What you do to the numerator, you do it to the denominator. Same thing with equations. What you do to one side of the equal sign, you do it to the other. So if I draw this line right here, I need to make sure that what happens on one side of the line happens on the other side. So I subtracted 15 so I could get rid of this 15 and get a by itself. 15 minus 15 is equal to 0. So it's like we canceled it out. Are you ready? Almost. Okay. And what I have left is a, which is what I wanted. See, that was our goal, to get a all by itself. But over on the other side, we have to go ahead and subtract that. Remember, you subtracted 15 from the left side, so let's subtract it from the right side to keep it balanced. And what do you have over here? 11. So you have A on this side all by itself and 11 on this side, so A equals 11. You can go back and check it. I'm going to rewrite the problem, but instead of writing A, I'm going to write our solution, 11 plus 15. Is that equal to 26? Yeah, it is. So that is our solution. For the next example, 5 equals W plus 1.5. If I draw my line right there, that's like the middle part of my scale. I have to keep it balanced. And remember, our goal is to not only balance out both sides of the equal sign, but we want to get that variable by itself. Remember, I was going to use the word variable instead of the word letter or letters. So W is over here this time. What do we want to get rid of so that we can get W all by itself? We want to get rid of the number, the constant, 1.5. So to get rid of it, you would subtract it. 1.5, okay, minus 1.5. But we also have to do it on the other side too, 1.5. Okay, so on this side over here, I just have W because these canceled out. And over here, I need to take 5 minus 1.5. Just subtract it. And that's 3.5. 3 and 5/10. So we say our solution is W equals 3.5. If you want to check it, just replace W with 3.5. 3.5 plus 1.5. If it doesn't equal 5, then you made a mistake somewhere, but it does. The next example, example 2, says y minus 21 equals 18. What is it? I'm not going to draw the line in the middle anymore because it makes a mess. But what is it that we want to get by itself? We want to get y by itself, which means we're going to have to get rid of this 21. What's different about this problem from the other ones is that this is y minus 21. So to get y by itself, you have to do the opposite. You're going to add 21. Think of it like if you were at negative 21 on the number line, you'd have to add 21 to get to 0. What we do to one side of the equal sign, we do to the other. So I'm going to add 21, and that is how we keep it balanced. These canceled out. If you wrote 42, then that means you didn't get rid of anything, and you don't remember your rules. What you're left with over here is y equals, and then go ahead and add 18 plus 21, and that's 39. Of course, you want to check it. Rewrite the problem, but instead of writing y, you're going to write 39. 39 minus 21 equals 18. Is that true? It is. Okay, the next problem. What do we want to get by itself? We want to get h by itself. So we're going to add a half. So add a half there, and then to keep it balanced, you add a half to the other side of the equal sign. These canceled out, and you're left with h equals, and now I need to add 3/4 plus 1/2. 3/4, I need a common denominator, times 2 times 2, so that's 2/4. 3/4 plus 2/4 is 5/4, which is equal to 1 and 1/4. This is probably a third grade skill now, but you definitely learned how to simplify fractions like this in 4th grade. You practiced it in 5th grade. Okay, last page. This problem involves this angle right here. I don't know what you remember about angles, but a straight angle from all the way around is 180 degrees. You're going to have to remember that. When you take this angle and you add it to this angle, it has to equal 180. That's what a straight line is. So, in my Cornell notes, I need to know what the other angle is. I have 60 so far, and I need it to equal 180. So you simply get x by itself by subtracting 60 here, subtracting 60 here, and that's x by itself now equals 120. All right, let's look at what number 6 says. Number 6, write an equation to find the measure of the unknown angle. Okay, so what do you remember about these kinds of angles? This is called a right angle. So if I add this angle plus this angle, that has to equal, well, how many degrees? 90 degrees. So 65 plus x equals 90. I want to get x by myself, so I'm going to get rid of the 65. It's a positive 65. To get rid of it, I need to subtract 65. And what you do to one side, you do to the other. Okay, and now we're left with x on this side, and then go ahead and subtract on the other side. 7 minus 6 is 15. So this must be 15 degrees. Okay, number 7 says, write and solve an equation to find the measure of a complement of an angle that measures 42. A complement is like this right here. 15 is a complement to 65 because when you add them together, it equals 90. So this complement is kind of like a fancy way of saying what would you add to 42 to make a right angle, to make 90. So 42 plus something. So here's the complement. We don't know what it is, so we're just going to say it's x plus 42 equals what? 90. Okay, let's get rid of the 42 and then keep it balanced. So the only thing I'm left with over here is x, and then do the math. X equals 48. So that means the other angle was 48. So if I had a 90-degree angle and one of them was 42, we just calculated the other one to be 48. And these two angles are complements. Because why? They add up to 90 degrees.